The Department of Education, Division of Tangub City, in partnership with the local government unit of Tangub, presents Ang Tangkub, Transforming Advancement in the New Normal, guiding K-12 learners under broadcast media and instructional program crafted in response to the need of making education possible and accessible to students at the comfort of their homes. It covers the most essential competencies thematically layered in drama plays which were originally written, directed, and performed by teachers to see to it that education is securely provided. This is Ang Tangkub.
Sa mga aral sa mundo, tayo na. Tumutok na sa TV, mag-aral ng maigi to get the lessons easily. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. Let's come and learn together, supporting one another. We love, we care, we share. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. Tangkub, tangkub time.
Welcome back mga grade 7 mathematics. Today is another brand new day to learn another lesson in mathematics.
Dito sa nag-isang programa nyo,
Ang Tangkub! We learn all things, ang saya! Ready na ba kayo?
hooray! Now, let us begin.
Today, in Mathematics 7, we will learn to calculate the measures of variability, range, average deviation, variance, and standard deviation of grouped data. It is important to calculate the measures of variability because it helps us to summarize a dataset with a single number. It tells us how reliable and how consistent the dataset around a single value. The measures of central tendency like mean, median, and mode is not enough. It provides us absolutely with no idea about the character of a data. In other words, how it represents the data. It is useful to supplement the information provided by the measures of central tendency. It also helps us to compare the different groups and compare the original data expressed in different units. At the end of this lesson, you will learn to calculate the measures of variability, range, average deviation, variance, and standard deviation of grouped data. When we say grouped data, it is the term used for a bigger quantity of collected data. This means the data is given in intervals.
In statistics, variability, also called spread or dispersion, refers to how spread out a set of data is. The four main ways to describe variability in a dataset are range, average deviation, variance, and standard deviation. Now, before calculating the measures of variability for grouped data, let us recall first the definition of grouped data. This is an example of grouped data. When we say grouped data, it is the term used for a bigger quantity of collected data. Grouped data is data given in intervals. Now, let us start with calculating range for grouped data. One simplest way to illustrate dispersion or how far away the data are from the center or average is the range. Now, to calculate the range of grouped data, use this formula. Range is equal to the upper class boundary of the highest interval minus the lower class boundary of the lowest interval. Note, when we say class boundaries, these are halfway points that separate the classes. Next, the upper class boundary of the highest interval is equal to the upper class limit of the highest interval plus 0.5. And the lower class boundary of the lowest interval is equal to the lower class limit of the lowest interval minus 0.5. Let us have an example. Solve for the range of the data shown below. Solution. Step 1. Find the following. What is the upper class limit of the highest interval? In the given dataset, the highest interval is 50 to 54. So, the upper class limit of this highest interval is 54. Next, what is the upper class boundary of the highest interval? Again, to get the upper class boundary of the highest interval, that is equal to upper class limit of the highest interval plus 0.5. So we now have 54 plus 0.5. 54 plus 0.5 is equal to 54.5. Thus, the upper class boundary of the highest interval is 54.5. Next, what is the lower class limit of the lowest interval? In a given dataset, the lowest interval is 25 to 29. So, the lower class limit of the lowest interval is 25. Now, how about the lower class boundary of the lowest interval? To get the lower class boundary of the lowest interval, again, it is equal to the lower class limit of the lowest interval minus 0.5. So, we now have 25 minus 0.5. 25 minus 0.5 is equal to 24.5. Thus, the lower class boundary of the lowest interval is 24.5. Step 2. Solve for the range using the formula. Range is equal to the upper class boundary of the highest interval minus lower class boundary of the lowest interval. Now, since the upper class boundary of the highest interval is 54.5, and the lower class boundary of the lowest interval is 24.5, then substituting these values into the formula, we now have range is equal to 54.5 minus 24.5. 54.5 minus 24.5 is equal to, right, 30. Therefore, the range of the grade 7 test scores in mathematics is 30. Easy, right? Now let's proceed to calculating the average deviation of grouped data. Again, when we say average deviation, it is also known as the mean absolute deviation or MAD. Average deviation is the average distance between each data point and the mean. It also describes how spread out a set of data is. Now, to calculate the average deviation of grouped data, we use this formula, where F is the class frequency, X is the class mark, and this symbol is the mean, and this symbol, summation of F, is the total frequency. Let us have an example. Calculate the average deviation of this given grouped data. Now, to calculate the average deviation of the given group data, we follow few steps. Step 1. Find the sum of the frequencies. Now, finding the sum of these frequencies, the result is 14. Thus, the summation of F, or the sum of the frequencies, is 14. Step 2. Get the class mark, or X, using this formula. X, or class mark, is equal to HB plus LB over 2, where HB is the higher boundary of the class interval and LB is the lower boundary of the class interval. Now, to get the first class mark, we follow the formula. X, or class mark, is equal to HB plus LB over 2. Now, in the interval 2 to 4, the HB, or the higher boundary, is 4, and the LB, or the lower boundary, is 2. So we now have 4 plus 2 over 2. 4 plus 2 is equal to 6. So we now have 6 over 2. 6 over 2, or 6 divided by 2, is equal to 3. So the first class mark is 3. Now, computing the rest of the class marks, following the same formula, we now have Step 3. Solve for fx, or the product of the frequency and class mark. Then get the sum. Now, computing for the first value of fx, just multiply the frequency and class mark. So we now have 2 times 3 is equal to 6. So the first value is 6. Now, computing for the rest of the values of fx, we now have, again, just multiply the frequency and class mark. Next, get the sum of the values of fx. So getting the sum of these values, we now have summation of fx is equal to, right, 92. Step 4. Solve for the mean. Solving for the mean of group data, we use the formula mean is equal to summation of fx divided by summation of f. Now, since summation of fx is equal to 92 and summation of f, or summation of the frequencies, is equal to 14, so substituting their values to the formula, we now have 92 over 14. 92 over 14, or 92 divided by 14, is equal to, right, 6.57. Thus, the mean of the given group data is 6.57. Step 5. Compute the absolute deviation. Note, this symbol is read as the absolute value of the class mark minus the mean. Now, computing the first absolute deviation, we now have absolute value of the class mark minus the mean. Now, since the first class mark is 3 and the mean is 6.57, so we now have absolute value of 3 minus 6.57. 3 minus 6.57 is negative 3.57. So we now have absolute value of negative 3.57. When we say absolute value, it is always equal to positive. So the absolute value of negative 3.57 is 3.57. So, the first deviation is right, 3.57. Now, computing for the rest of the absolute deviations, we now have, again, just get the absolute value of the class mark minus the mean. Step 6. Solve for the product of the frequency and the absolute deviation, then get the sum. For the first value of the product of the frequency and the absolute deviation, we now have 2 times 3.57. 2 times 3.57 is equal to 7.14. So the first value is 7.14. Now computing for the rest of the values, we now have, again, just multiply the frequency and the absolute deviation. Now, getting the sum of these values, we now have 23.72. Last step, calculate the average deviation using this formula. Now, since the summation of the product of the frequency and the absolute deviation is 23.72, and the summation of f, or summation of the frequencies, is 14, then substituting these values to the formula, we now have 23.72 over 14. 23.72 over 14, or 23.72 divided by 14, is equal to 1.69. Thus, the average deviation or the mean absolute deviation of the given grouped data is 1.69. Do you get it? Good. Now let's proceed to calculating the variance and standard deviation of grouped data. Now to calculate the variance and standard deviation of grouped data, we use this formula. For variance and for standard deviation, where f is the class frequency, x is the class mark, this symbol is the mean, and this symbol or the summation of f is the total frequency. Note, standard deviation is the square root of the variance. Let us have an example. Calculate the variance and standard deviation of this grouped data. Again, to calculate the variance and standard deviation, we follow a few steps. Step 1. Find the sum of the frequencies. Now, getting the sum of these frequencies, we now have, thus, the sum of the frequencies is 14. Step 2. Get the class mark or x using this formula. X or class mark is equal to HB plus LB over 2. Again, HB is the higher boundary of the class interval and LB is the lower boundary of the class interval. So to get the first class mark, we follow the formula. Again, since in the interval 2 to 4, the higher boundary is 4 and the lower boundary is 2, so we now have 4 plus 2 over 2. 4 plus 2 is equal to 6, so we now have 6 over 2. 6 over 2, or 6 divided by 2, is equal to 3. So, getting the rest of the class marks, just follow the same formula. Step 3. Solve for fx or the product of the frequency and the class mark. So to get the first value of fx, just multiply the frequency and the class mark. So we now have 2 times 3. 2 times 3 is equal to 6. So the first value of fx is 6. Getting the rest of the values of fx, we now have Step 4. Solve for the mean. Solving for the mean of group data, we use the formula. Since the summation of fx is equal to 92 and the summation of f is equal to 14, so we now have 92 over 14. 92 divided by 14 is equal to 6.57. Thus, the mean of the given group data is 6.57. Next step, compute the absolute deviation. Again, to compute the absolute deviation, we get the absolute value of the class mark minus the mean. For the first value of the absolute deviation, we now have absolute value of the class mark minus the mean. Since the class mark is 3, So we now have absolute value of 3 minus the mean, which is 6.57. 3 minus 6.57 is equal to negative 3.57. So we now have absolute value of negative 3.57. Absolute value is always positive, so the absolute value of negative 3.57 is positive 3.57. So the first absolute deviation is 3.57. Now getting the rest of the values of the absolute deviations, we now have Step 6. Square the deviation. Squaring the first deviation, we now have the square of 3.57 is equal to 12.7449. So, squaring the rest of the deviations, we now have Step 7. Solve for the product of the square deviation and the frequency, then get the sum. Now computing for the product of the square deviation and the frequency, we now have 2 times 12.7449. 2 times 12.7449 is equal to 25.4898. So, solving for the product of the rest of the square deviations and the frequencies, we now have Now getting the sum of these values, we now have 65.4286. And lastly, calculate the variance and standard deviation. For the variance, we follow this formula. Now, since the sum of the product of the frequency and the square deviation is 65.4286, and the summation of f or summation of frequencies is 14, so we now have 65.4286 divided by 14 minus 1. 14 minus 1 is equal to 13. So we now have 65.4286 over 13. 65.4286 over 13 or 65.4286 divided by 13 is equal to 5.03. Thus, the variance of the given group data is 5.03. Now, how about for standard deviation? For standard deviation, we know that standard deviation is the square root of the variance. So we now have standard deviation is equal to square root of 5.03. Square root of 5.03 is equal to 2.24. Thus, the standard deviation of the given group data is 2.24.
To calculate the measures of variability, range, average deviation, variance, and standard deviation of a given data, we follow the following steps. Step 1. Identify if the given data is grouped or ungrouped data. Step 2. Calculate the measures of variability, range, average deviation, variance, and standard deviation of the given group data based on the steps mentioned in the key concept. Now, let us calculate the measures of variability of the given data below. Following the steps, Step 1. Identify if the given data is grouped or ungrouped data. Well, the given data set is grouped data, since the data is in intervals. Step 2. Calculate the measures of variability, range, average deviation, variance, and standard deviation of the given group data based on the steps mentioned in the key concept. Now, to calculate for the range, we follow some steps. Step 1. Find the upper class limit of the highest interval. The upper class limit of the highest interval is 21. Next is the upper class boundary of the highest interval. To get the upper class boundary of the highest interval, we need to add 0.5 of the highest interval. So we now have 21 plus 0.5, and that is equal to 21.5. Next, lower class limit of the lowest interval. The lower class limit of the lowest interval is equal to 10. Then next is the lower class boundary of the lowest interval. To get the lower class boundary of the lowest interval, we need to subtract 0.5 from the lowest interval. So we now have 10 minus 0.5, and that is equal to 9.5. Next step, solve for the range using the formula. The formula for the range is equal to upper class boundary of the highest interval minus lower class boundary of the lowest interval. So we now have 21.5 minus 9.5, and that is equal to 12. Thus, the range of the number of orders is equal to 12. Now, to calculate for the average deviation, we follow some steps. Step 1. Find the sum of the frequencies. The sum of the frequencies we have is 4 plus 12 plus 20 plus 14, and that is equal to 50. Step 2. Get the class mark using the formula x as the class mark is equal to HB plus LB over 2. HB means higher boundary of the class interval. LB means lower boundary of the class interval. Our first class interval is 10 to 12. So to get the class mark of this first class interval, we now have higher boundary that is equal to 12 plus the lower boundary that is equal to 10. So we now have 12 plus 10 over 2. 12 plus 10 is equal to 22. So we now have 22 over 2. 22 over 2 is equal to 11. So the class mark of the first class interval 10 to 12 is equal to 11. The next class interval is 13 to 15. To get the class mark of this class interval, we now have higher boundary that is equal to 15 plus the lower boundary that is equal to 13. So 15 plus 13 over 2. 15 plus 13 is equal to 28. So we now have 28 over 2. 28 over 2 or 28 divided by 2 is equal to 14. So the class mark of the class interval 13 to 15 is equal to 14. Do the same process for the next class intervals. Step 3. Solve for f of x or the product of the frequency and class mark, then get the sum. So for the first class interval, our f of x is equal to 4 times 11. 4 times 11 is equal to 44. The next class interval we have is 12 times 14. 12 times 14 is equal to 168. The next is 20 times 17. 20 times 17 is equal to 340. Next is 14 times 20. 14 times 20 is equal to 280. Now let's get its sum. 44 plus 168 plus 340 plus 280 is equal to 832. Step 4. Solve for the mean. Solving for the mean of group data, we use the formula the summation of f of x divided by the summation of f. The summation of f of x is equal to 832. The summation of f is equal to 50. So divide the 2. 832 divided by 50 is equal to 16.64. So the mean is equal to 16.64. Step 5. Compute the absolute deviation. Computing for the absolute deviation means the absolute value of the difference between class mark and the mean. Now computing for the absolute deviation of the first class interval, we now have the absolute value of 11, the first class mark, minus the mean 16.64. The absolute value of 11 minus 16.64 is equal to 5.64. Now for the second class interval, we now have the absolute value of 14 minus the mean 16.64. The absolute value of 14 minus 16.64 is equal to 2.64. The absolute deviation of the next class interval is the absolute value of 17 minus 16.64. The absolute value of 17 minus 16.64 is equal to 0.36. Then next is the absolute value of 20 minus 16.64. The absolute value of 20 minus 16.64 is equal to 3.36. Step 6. Solve for f of average deviation, or the product of the frequency and the absolute deviation, then get its sum. To get the product of the frequency and the absolute deviation of the first class interval, we now have 4 times 5.64, and that is equal to 22.56. For the second class interval, we now have 12 times 2.64, and that is equal to 31.68. Next, 20 times 0.36 is equal to 7.2. And lastly, 14 times 3.36, that is equal to 47.04. Now getting its sum, we have 22.56 plus 31.68 plus 7.2 plus 47.04, and that is equal to 108.48. Step 7. Finally, calculate the average deviation using the formula. Summation of f of average deviation minus summation of f. Since the summation of f times the average deviation is equal to 108.48 and the summation of f is equal to 50, then substituting these values to the formula, we now have 108.48 divided by 50. 108.48 divided by 50 is equal to 2.17. Thus, the average deviation or the mean absolute deviation of the given group data is 2.17. Now we're ready to calculate for the variance and standard deviation. Steps 1 to 5 in calculating the variance and standard deviation is similar as the steps in calculating the average deviation. Step 6. Square the deviation. Squaring the deviation of the first class interval, we have 5.64 squared. 5.64 squared is equal to 31.8096. Next, squaring the second average deviation, we now have 2.64 squared. 2.64 squared is equal to 6.9696. Squaring the third average deviation, we now have 0.36 squared, and that is equal to 0.1296. And lastly, 3.36 squared is equal to 11.2896. Step 7. Solve for the product of the square deviation and the frequency. Then get its sum. Now to get the product of the frequency and the square of the average deviation of the first class interval, we now have 4 times 31.8096, and that is equal to 127.2384. The next class interval is, we have 12 times 6.9696, and that is equal to 83.6352. Next class interval, we have frequency 20, and the square of the average deviation is 0.1296. Multiply the two, we can have the product 2.592. And the last class interval we have is 14 times 11.2896, and the product is 158.0544. Getting its sum, we have 127.2384 plus 83.6352 plus 2.592 plus 158.0544. We can get the sum equal to 371.52. Step 8. Finally, calculate the variance and the standard deviation. In calculating the variance, we follow the formula. Variance is equal to the summation of f times the square of the average deviation over the summation of f minus 1. The summation of f times the square of the average deviation is equal to 371.52, and the summation of f is equal to 50. Substituting this value, we now have 371.52 divided by 50 minus 1. 50 minus 1 is equal to 49. So we now have 371.52 divided by 49, and that is equal to 7.58. Thus, the variance of the given group data is 7.58. Next, standard deviation. In getting the standard deviation, we just simply get the square root of the variance. Since our variance is 7.58, getting its square root, we now have 2.75. Thus, the standard deviation of the given group data is 2.75.
Now, since you know already how to calculate the measures of variability for grouped data, then it's time to get your activity sheet in this lesson and answer the given activity. Take your time in answering the activities.
If you have questions or clarifications, you may contact the number of your teacher printed below your activity sheet. To end, always remember that the essence of mathematics is not to make simple things complicated,
But to make complicated things simple.
Grade 8 learners, stay tuned and get ready for Math 8 is coming next. Good luck and God bless everyone! Hello! Welcome back mga grade 8 Mathenics!
Today is another brand new day to learn another lesson in mathematics.
Dito sa nag-isang programa nyo,
Ang Tangko! We learn all things ang saya! Ready na ba kayo?
Hooray! Now, let us begin!
Today, we will learn on how to illustrate an experiment, outcome, sample space, and event. Importance of the lesson. Probability plays a vital role in the day-to-day life. In the weather forecast, sports and gaming strategies, buying or selling insurance, online shopping and online games, determining blood groups, and analyzing political strategies. Perhaps, the most common real-life example of using probability is weather forecasting. Probability is used by weather forecasters to assess how likely it is that there will be rain, snow, clouds on a given day in a certain area. At the end of the lesson, you will illustrate an experiment, outcome, sample space, and event.
Have you ever heard a weatherman says, there is a 40% chance of rain tomorrow? Or a volleyball referee tells a team there is a 50-50 chance of getting heads on a coin toss to determine which team starts the game. These are probability statements. Now learners, stay tuned and bear with us today. For today's lesson, we will be going to investigate probability and how likely it is that some events will occur. Probability is the chance that something will happen. Events cannot be predicted with total certainty. We can say how likely they are to happen. Now, there are ways of showing probability. Probability goes from 0, that is impossible, up to 1, where that is certain. For example, consider a box that contains only red cubes. If you were to select from the box, you are certain to pick a red one. We say that an event that is certain to happen has a probability of 1. If we were to reach into the same bag of cubes, it is impossible to select a yellow cube. An impossible event has a probability of 0. Probability is often shown as a decimal or fraction. Example, the probability of getting a head when tossing a coin, as a decimal we could have 0.5. As a fraction, we can have 1/2. As a percentage, we can have 50%. Or sometimes, it is like this, 1 in 2. Now what about probability experiment? Probability experiment is a chance process that leads to a well-defined result called an outcome. Examples are flipping a coin or rolling a die. And when we say outcome, it is the result of a single trial of an experiment. Here is an example. Flipping a coin is an experiment. An outcome would be head or tail. Another experiment is rolling a die. Outcome, it could be 1, 2, 3, 4, 5, or 6. Do you get it? Now let us proceed to sample space. Sample space is the set of all the possible outcomes or sample points. When we say sample point, it is just one of the possible outcomes. Here are the examples. Flipping a coin is an experiment. A sample space could be HH, or that means head-head, or it could be HD, or that is head-tail. It could be TH, or tail-head, and TT, or tail-tail. Sample point could be HH. That's it for sample space. Now let us have an event. Event is any set of one or more outcomes satisfying some given conditions. Event is a subset of sample space. Here are examples. Getting a TTT or tail-tail-tail when flipping a coin thrice. Choosing a queen from a deck of cards, or that is any of the 4 queens. Or it could be getting an odd number, 1, 3, or 5 when rolling a die.
To illustrate an experiment, outcome, sample space, and event, used a graphical representation which is a Venn diagram. In general, the sample space S is represented by a rectangle, outcomes by points within the rectangle, and events by ovals that enclose the outcomes that compose them. Let us consider illustrative example 1. The image below shows the 2 sides of a standard 1 peso coin. Suppose that a coin is tossed. Illustrate an experiment, outcome, sample space, and event using a Venn diagram. In the Venn diagram, the sample space is represented by a rectangle with an H and T. H stands for head and T stands for tail. The outcomes are points beside H and T within the rectangle, and the event is enclosed by oval, which is the point T. Let's proceed illustrative example number 2. Suppose you roll a die once. Illustrate an experiment, outcome, sample space, and event using a Venn diagram. In the Venn diagram, the experiment is rolling a die. The sample space is represented by a rectangle with 1, 2, 3, 4, 5, and 6. The outcomes are points beside 1, 2, 3, 4, 5, and 6 within the rectangle. And the events are enclosed by ovals, which are the set of 4, 5, and 6, or set of 3 and 6.
Complicated?
No! Then it is time to get your activity sheet in this lesson and answer the given activities. Just take your time in answering the activities.
If you have questions or clarifications, you may contact the number of your teacher printed.
And always remember that learning is a treasure that will follow its owner everywhere.
So, education must continue. Grade 9 learners, stay tuned and get ready for Math 9 is coming next.
Good luck and God bless everyone!
Welcome back mga grade 9 mathematics.
Today is another brand new day to learn another lesson in mathematics.
Dito sa nag-isang programa nyo,
Ang Tangko! We learn all things, ang saya! Ready na ba kayo?
Hooray!
Now learners, today we will learn how to explain the law of cosines. Now, why do we need to study this lesson? Just like law of sines, law of cosines can also be used to solve problems involving oblique triangles. Particularly, the law of cosines is useful for calculating the third side of a triangle when two sides and their included angle are known, and also in calculating the angles of a triangle if all three sides are known. Learners, take note that at the end of this lesson, you will explain the law of cosines by calculating the unknown sides and angles of an oblique triangle. The law of sines and the law of cosines are useful in solving for parts of an oblique triangle if certain other parts are known. Remember, an oblique triangle is a triangle with no right angle. It has either three acute angles or one obtuse angle and two acute angles. In any case, as in any triangle, the sum of all three angles is equal to 180 degrees. The law of cosines states that the square of one side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of these two sides and the cosine of their included angle. In symbols, in any triangle ABC, a squared is equal to b squared plus c squared minus 2bc times cosine a. b squared is equal to a squared plus c squared minus 2ac times cosine b. And lastly, c squared is equal to a squared plus b squared minus 2ab times cosine c. To find an angle given the three sides, it is easier to use the direct formula, which is just a rearrangement of the formula c squared is equal to a squared plus b squared minus 2ab times cosine c. It can be either of these forms. The law of cosines is used in the following cases. First, the SAS case. Two sides and the included angle are known. Second, the SSS case. Three sides of the given triangle are known. Now, how to explain the law of cosines by calculating the unknown sides and angles of an oblique triangle? Well, we follow few steps. Step 1. Write the given information and determine if the given information form either of the following cases: the SAS or side angle side case or the SSS or side case. Step 2. Calculate for the unknown parts of the triangle, applying the law of cosines. Let us have examples. Example number 1. Given an oblique triangle below, explain the law of cosine by calculating side C. Solution. Again, we follow few steps. Step 1. Write the given information and determine if the given information form either of the following cases: SAS or side angle side or the SSS or side case. Now, based on the given figure, the given information are side A is equal to 8, side B is equal to 12, angle C is equal to 80 degrees. Take note that angle C here is the included angle of the two given sides, side A and side B. The unknown in this example is, the side C. Now, the given information shows, the SAS or the side angle side case, since the two sides and an included angle of a triangle are given. This means that we can apply law of cosine to calculate for the unknown, which is side C. Step 2. Calculate for the unknown parts of the triangle applying the law of cosines. Now, since side C is the unknown, applying the law of cosines, we now have c squared is equal to a squared plus b squared minus 2ab times cosine of angle C. This is by the law of cosine. We use this formula if side C is unknown. Now, substituting the given information or values, we now have c squared is equal to 8 squared plus 12 squared minus 2 times 8 times 12 times cosine of 80 degrees. Simplifying, 8 squared is equal to 64. 12 squared is equal